A good old further trig question. Now, the thing I love about these types of questions, right, when you're asked to show something, there's really two things I want to say about that. First of all, they're actually kind of giving you the answer already, right? They're giving you what you need to arrive at. In saying that, you don't actually get any marks in the exam kind of situation. You're not getting any marks for something like this, right? So you need to make sure when you're doing a show question, every step along the way is very clear what you're actually doing and how you actually got that result. In saying that though, although you can't actually get marks for writing that result, you can use the result as a bit of a hint of where to go next. What do I mean by that? Well, when I'm looking at this, I've got this triangle here, I've got all of these kind of labeled sides, A, B, C, and D. I even have some angles and some lengths, and to be honest, it's a little bit overwhelming with all the information we've got going there. Let's try and filter it out a bit, and let's have a look here and see what we're asked to show. We're asked to show that BC, so this line here, is equal to h times cos alpha. So h cos alpha, I can see there's an alpha there, all divided by sine alpha plus beta. Okay, so a couple of things when I'm thinking about this. I want to make sure I know my trig identities well, my various trig rules like sine and cosine rule and things like that. Also recognize that anytime you see cos alpha, that's something that can represent, for example, a ratio of sides, or maybe you need to use a complementary result or something like that. A lot of things you want to keep in mind. We are going to have to use a combination of all those to start this problem, right? So the first thing that I notice is that what we have here is I've got sine alpha plus beta, and that kind of jumps out to me. The reason why is because generally when we look at like a single trig ratio, you can use that in a right angle triangle, but sine alpha plus beta, that's sort of incorporating both of these angles, right? Which is not in a right angle triangle as you look at the whole thing ABC. So that kind of makes me want to focus on that. The other thing is I noticed that they incorporate h here, right? And h is the opposite side to that angle. And you might start be thinking now, oh, okay, I can see where this is headed, right? When you have an opposite side divided by its opposite angle, that usually incorporates sine rule. So can you see how I'm using this result that I'm asked to prove to try and show that? So how could we use sine rule here? Well, why don't we start off with what we just said, right? So part A, and again, I'm using very clear steps of what I'm doing. I'm saying using sine rule, I can say that, okay, I know that h over this, so h on sine alpha plus beta, what would that be equal to? Well, that's equal to any other angle or side that I choose. And this is where you want to be a bit strategic with how you choose that, right? Incorporate the other components of what you have here. You've got BC, okay, that's the side. What's its opposite angle? Well, it's over here. Don't really have anything there at the moment, but I can just leave it as angle A. Let's use it for now, right? I can say that BC all divided by sine of angle A, all right? Probably should say CAB, but angle A, you know what I'm talking about there. What can I do next? Well, a bit of rearranging here, right? Because they've got BC as the subject, so I could do that. Multiply both sides by sine of angle A. And we'll tidy it up a bit, move, swap the sides, I suppose, and put this on the numerator. So, like surprisingly, not too many steps, and we've actually gone quite a significant way, right? There's only one thing that's missing now. Somehow, they've got that sine alpha is equal to cos alpha over here. So this is where I'm trying to use what I'm asked to prove to try and get that result. So sine alpha I can see is this over here. Sine alpha I can think as a ratio. Sorry, not sine alpha, sine A. Sine A would be like CD opposite over hypotenuse, so CD over AC. I wonder what else I can do with this. Well, you also see that you actually have a right angle triangle here, right? So in actuality, you know an expression for this angle. This angle would just be 180 minus 90 minus alpha, right? Which would simplify to just 90 minus alpha. So this is no longer just sine of angle A, you can write it as sine of 90 minus alpha. Now why is that useful? Well, because every trig ratio has something called its complementary ratio. And that means that there's an identity that says that if you take 90 minus that, minus some angle, it's equal to the same as just alpha. And in this case, right, the complementary of sine is cosine. That's why we call it cosine, because there's a co in front of it, it's a complementary angle. So when you find cos alpha, right, think about using that as a trig ratio, adjacent over hypotenuse, that would be equal to CD over AC as well. So you can see that these are equivalent expressions, right? So this is an identity you need to be aware of. And what you can do is now you can substitute in, I should have that working out here, right? You can substitute that in as cos alpha. Well, actually, I'll do another thing. I'll write this as sine 90 minus alpha first. And then h on cos alpha all over sine alpha plus beta, okay, as required. So you can see how I haven't skipped any steps. I've made it really clear this working out, where I got these results from, and I've showed that result there. Okay, so that's part A. Part B now says, hence show that x is equal to, boom, another big expression. Another thing to say, right, hence, anytime you see that, really you have to use what you've been given here. Sometimes they'll say hence or otherwise, so you've got the option there, but it's generally leading you towards using the result that you've just gotten in a previous part. And you can see why, right? Because visually, these two expressions are quite similar. The only difference is somehow they've incorporated x here, and we've got a sine beta here. So in a sense, you can almost kind of reverse engineer this to try and see what they've done here, right? So what they have done, they've incorporated that. If I try and get this sine beta back to the other side, really you just divide both sides by sine beta, right? So you're really trying to show that x on sine beta is equal to h cos alpha over sine alpha plus beta. Now, why have I done that? Well, again, this is not a part of the formal proof, by the way, but this is just a way to think about where do I actually want to go from here. And you can see that this is meant to be the same as BC, right? Because these two expressions are the same. So that must mean that BC is x on sine beta. Where would that come from? Well, BC is over here, right? Which is just a part of this right angle triangle here. So what we can say is, okay, thinking about how to incorporate sine beta in this expression, I can say sine beta, and remember, what is sine? Well, sine is just opposite of hypotenuse, right? So opposite over hypotenuse, so I'm getting x over BC. Sorry, whoops, x over BC. So sine beta is opposite of hypotenuse, x over BC. And we want to try and substitute BC as that expression. So let's rearrange so that's the subject. And so BC is equal to x on sine beta. So you can see how it's all coming together now, right? And then substituting into the result from part A, we're going to get x on sine beta is equal to h cos alpha sine alpha plus beta, and then multiply both sides by sine beta. We're going to get this result here. So I multiply both sides by sine beta and just chucked it into the numerator there as required. So again, right, two clear things we want to do. We want to make sure that we're not just using the result and reverse engineering it. Like, we can use it as a clue, and I've done that here, right? But when you're doing that, you want to be writing a formal proof, and you also want to be very clear about what you're doing. You can say I've written that I'm substituting into the result from part A, and that's just to give the marker an indication of, okay, I actually know what I'm doing. I'm not just kind of making up some results so I can get to that endpoint, okay? So that's a further trig show type questions. A lot of things going on there, but that's how you can structure out your answer for a question like this.